Okay, we got a few more problems we're going to work through. So on this problem, I can't pick out my x and my y-intercept. So I need to solve for y first. So I'm actually going to bring up this problem here. I'm going to flip-flop the equal sign around. So I've got 3/4 y minus 6 equals x. So all I did was flip-flop these two sides. Okay, and then what I want to do is I want to solve for y. So I'm going to actually multiply everything by 4 because I want to get rid of this fraction. So I'm going to multiply everything times 4. What that gives me is it gives me a 3y minus 24 equals 4x. Then what I can do is add 24 to both sides. And so I get 3y equals 4x plus 24. And then I can divide by 3. So that gives me y equals 4/3 x plus 8. So I'm going to be able to graph this now using m as 4/3 and my b value as 8. So I'm going to be using that. So I'll mark 8. And I need to go up 4. Well, I can't go up 4 because I'm running out of graphs. So I'm going to go down 4. 1, 2, 3, 4. That's a negative 4. Over to the left 3. That's a negative 3. So I went down 4 to the left 3. Down 4 to the left 3, and I will graph that line. The second one I'm going to do is right here, and all I really need to do is solve for y. So I'm going to add this 3/4 x to both sides. That gives me y equals 3/4 x plus 8. So that makes my b also 8, and my m is 3/4. So I can already tell you where it's going to intersect because I got the same b value. So I'm going to plot 8 there, and I'll go up 3, which I can't do. So I'll go down 3, 1, 2, 3. To the left 4, 1, 2, 3, 4. So I still have that positive slope. It is going to be intersecting right here at 0, 8. Now I'm not going to plug this back in to check the solution due to the time in the video. The next one we're going to do is an x equals equation. I haven't done a whole lot of these. When you graph something like this, you can always use t-charts. What this means is that x is always 1. So I can put 1 a ton of times for x. It doesn't matter. It's always 1. And then it doesn't matter what x is 1, y can be whatever I want it to be. So I'll just pick a bunch of different numbers. But x is always 1 because that's exactly what it says. So if I plot 1, 0, I'd be here 1, 1, 1, 2, 1, 3. So what I get is a vertical line, something with undefined slope. This second one I will plot by using my slope of 1/2, and my b value is 4. I should change the color of for each line, but I'm not going to on this problem. So my y-intercept is 4, plot my 4, and then I'm doing rise 1, run 2. Now on this one, this is one where we don't have the exact intersection. I'm not typically going to give you problems like this for graphing. We'll deal with more of the fraction type answers with the other types of ways we're going to solve. Because graphing, it's hard to see otherwise. I can see that it's basically going between 4 and 5 though, so I'm going to say this intersection is 1, 4.5. Okay, this next one we're going to do, this is the last one in this video and the last one for this section. I first need to solve for y, so I'm going to change this to plus the opposite. I'm going to subtract 3x from both sides. That gives me a negative y equals negative 3x plus 9. Then I can divide by negative 1. Y equals 3x plus negative 9. Plot my negative 9. Rise 3, run 1. Rise 3, run 1. Rise 3, run 1. I can do this many, many times. Rise 3, run 1. Connect my dots together. The next equation, I will have my m is, there's a 1 sitting right here, so m is 1. We can write that as a fraction, 1 over 1. And my b value is actually 0 because there's like a plus 0 here. So my y-intercept is 0. I'm going to rise 1, run 1. 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 Again, I've got one of these cases where they don't match up evenly. So I'm going to have to say this is approximately, it's between 4 and 5. So I'll say it's 4.5, comma. Here it's between 4 and 5. So I'll say 4.5, comma 4.5 as my solution.